Hello, my name is Nick Vu. This is my presentation for ENV-ENG 746 assignment 2B. This is my final project assignment at Handon, and I'll start my assignment. To talk about the project aim, this project is about identifying or investigating how water temperatures driven by different climate changes affect the nitrogen-driven eutrophication and water quality in Mangapa River. The objective of this project, or the research, is to identify if the effect of the temperature on dissolved oxygen and algal growth and nitrogen transformation changes as the temperature rises. So I will simulate water quality scenarios using stellar models. Also, I'll be using two scenarios to understand the future models if possible, assessing how warming amplifies eutrophication through enhanced microbial and algal activity. Also identify critical temperature thresholds that signal water quality deterioration. The Mangapa River at Otorohanga is not only ecologically important but also culturally significant. The area has historical values and the local heritage linked to the traditional gardenership and natural landmarks, including the protection of significant native trees and surrounding biodiversity. However, the recent water quality assessment indicates that the river is increasingly unsuitable for recreational use, so elevated levels of E. coli, nutrition runoffs, and declining water clarity, especially after rainfall, have led to the regular exceedance of recreational health guidelines. This shift from culturally valued potential recreational sites to degraded waterways highlights the urgency for action to restore and protect both its ecological and cultural integrity. The Mangapa River at Otorohanga is a soft bottom streamed borderline mainly in the farmland or dairy farmlands. And the Waipa River, which is just under Otorohanga, is also a similar degradation downstream with poor water quality and odor. So both these, we talk about it in the project, as high nitrogen and phosphorus level is affecting these streams, and the post-rainfall pollution events highlights how vulnerable the area is to runoffs and climate-driven stresses. In this section, I'll briefly outline the methodology used in the study. The model is based on three main models, or components: algal growth, nitrogen cycle, and the stellar model. So each of these play a very crucial role in how the temperature affects the water quality, and in finding out in the following slides, I'll also go over the details of how each element is used to simulate the impact. So in this study, I modeled algae growth in stellar models by treating algae as a stock, and this increased the growth and decreased the wealth and losses with like how respiration and settling works. So the main two components that helps the algae's growth is temperature and the nitrogen availability. How nitrogen actually fuels up the ammonia, using especially the ammonia, and the temperature itself. As the water gets warmer, algae grows faster. I used the modified model equation to calculate this, adjusting the growth rate based on the nitrogen concentration and the temperature scenarios at 13 degrees and 16 degrees. Algae losses included through fixed rates for respiration and settling, based on the typical values for the local streams, and together to set up allowed me to simulate how warmer temperatures and high nitrogen levels can accelerate eutrophication in Mangapa River. To simply talk about the nitrogen cycle, it starts with organic environment, where organic nitrogen comes from the dead plants and animals and farm runoffs into not directly usable algae, but actually go through hydrolysis. And then when it becomes ammonia, bacteria breaks down organic nitrogen into ammonia, and then formed algae that can be used. And then this ammonia goes through nitrifications. Other bacterial converts ammonia into nitrite and also nitrate to go through a two-step process where nitrate is also usable by algae. So what it matters is the warmer temperature makes these steps faster, and with increasing nitrogen availability, the fuel algae growth, leading to eutrophication. So using the stellar architect model, the process begins by identifying key biochemical affecting urban water quality. So these are to analyze and understand the behavior of limitations and maintaining healthier water conditions. So overall, the reason we are actually using the stellar architect model is to finally date and model the stellar architect to visually represent the impact of these biochemical through dynamic graphs and tables. To conclude about the recommendations as well, so the Otorohanga city itself we can see that the actual 3%, 3 degrees in temperature, water temperature, is actually affecting the algal blooming, and also in the nitrogen cycle, where the nutrition in the river stream is actually increasing and rising at a dangerous level. So what I can recommend is improving the water flow and hydrology systems around the place, existing infrastructure and land use, pollution sources and land characteristics, population density and growth trends, and site characteristics, physical landscapes, or regulatory environment goals. So all these are recommendations for manipulating and try to save the actual. Thank you for listening to my presentation. These are the reference for the photos and the data point that I got.